Hey there, and welcome. Today we are jumping headfirst into one of the most game-changing technologies out there, large language models. You know them as LLMs. They're popping up everywhere, completely shaking up how we work, how we create, and even how we talk to each other. So let's cut through all the hype and get right down to what makes them tick.
All right, here's the plan. First, we're going to pull back the curtain on the magic trick that started it all, the transformer. Then, we'll walk through the LLM family tree and see just how fast it's grown. After that, we'll look at how these brainy models get even smarter for specific jobs. And finally, we'll check out how they're being fine-tuned for the real world.
You know, literally everything in the world of modern AI and LLMs starts right here, with a brilliant piece of engineering called the transformer. And the wild part, it wasn't even designed to be a chatbot. Nope. It came out of a Google project back in 2017 that was just trying to get better at language translation.
To really get why the transformer was such a breakthrough, you have to understand the problem it was trying to solve. I mean, think about it. How does a computer read a sentence and just get the relationships between all the words, especially a tiny little word like it? How does it know what it is talking about?
Okay, look at this sentence. For us, it's a no-brainer. It obviously means the tiger. But for a machine, that connection isn't automatic. The AI needs a way to figure out that it points back to tiger to understand what's really being said. And that is the exact problem the transformer was built to crack. So, before any of that magic can happen, the text needs a little prep work. First, the sentence gets chopped up into little pieces called tokens. Then, each of those tokens gets turned into a long list of numbers, a vector, which is kind of like its mathematical fingerprint of meaning. That's called embedding. And finally, since transformers look at all the words at once, we have to add a little note about where each word was in the original sentence.
And that brings us to the secret sauce, self-attention. This is how we solve that thirsty tiger problem. For every single token, the model creates three things: a query, a key, and a value. You can think of it like this. The query from the word it is like it's raising its hand and asking, hey, who in this sentence is most important to me? The key on every other word is like a name tag. The word tiger has a name tag that says, I'm the main animal here. The model sees the query from it matches the key from tiger really well, and then it pulls the value, the actual meaning and context from the word tiger. That's how it builds connections. It's brilliant.
Now, the original transformer had two main parts: an encoder that would read and understand the first language, and a decoder that would write out the translation. But for a lot of the LLMs we use today, like chatbots, they really only need to generate text, so they often use a simpler, decoder-only architecture. It's just more efficient for spitting out the next word in a sentence.
So as these models got absolutely massive, they got kind of slow. The solution? A really clever idea called mixture of experts. Instead of having one giant brain do all the thinking, imagine a team of specialists. A smart little gating network acts like a traffic cop, looking at a problem and sending it to just the one or two experts who are best at that specific thing. This means you can have a model with trillions of parameters, but you're only using a tiny fraction of them at any given time, making it super fast and efficient.
The thing to remember is that the 2017 transformer paper wasn't the finish line. It was the starting pistol. What came next was a total explosion of research and development, creating this huge, rapidly evolving family tree of amazing models. I mean, the pace has just been insane. In 2018, you had the first big ones, GPT-1 and BERT. A year later, GPT-2 showed up with new tricks. Then came the behemoth, GPT-3 in 2020. Then in 2022, a paper called Chinchilla completely changed how we train these things, which led to the giants we have today like the Palm and Gemini models. It's just wow, the speed is something else.
Now, one of the first truly mind-blowing moments came with GPT-2. It showed off this wild ability called zero-shot learning. What that means is you could ask it to do something it had never, ever been specifically trained to do, just by describing the task in the prompt. It was the first real hint that these models weren't just memorizing things. They were starting to, well, generalize.
For a long time, the motto in AI was just, make it bigger. But then, this paper on a model named Chinchilla came out in 2022 and turned that whole idea on its head. It basically proved that if you have a limited amount of computing power, you get a much smarter model by training a slightly smaller one on way more data. This single insight changed the entire industry's strategy overnight. It was no longer just about size. It was about the perfect ratio of size to data.
Okay, so now we've got these huge, powerful foundation models. But you can think of them like a brilliant college grad who knows a little bit about everything. To get them to be truly great at one specific job, you need to give them some specialized training.
And that training happens in two big steps. First up is pre-training. This is where the model just reads a massive chunk of the internet, books, articles, websites, to learn grammar, facts, and just how language works. That's the super expensive general education. Then you have fine-tuning. That's where you take that smart, pre-trained model and give it a smaller, focused data set to turn it into an expert on one thing, like writing code or answering customer service questions. But fine-tuning a whole multi-billion parameter model is crazy expensive. So that's where these clever techniques called PFT, or parameter efficient fine-tuning, come in. The idea is brilliant. You freeze all the billions of original settings in the model, and you just add a few new tiny modules that are trainable. It's like adding a turbocharger to an engine instead of rebuilding the whole thing from scratch. It makes customizing these models so much cheaper and faster.
So, besides the training, how we actually talk to the model is hugely important. That's called prompt engineering. You can do a simple zero-shot prompt, which is just a direct command, or you can do a few-shot prompt, where you give it a couple of examples of what you want. But for really tough problems, chain-of-thought prompting is a total game-changer. You actually show the model the steps to reason through a problem, which helps it learn to think more logically itself.
Right, so we've got these super smart, specialized models. The last part of this whole story is making them actually work in the real world. And that means making them fast, making them efficient, and, actually using them to do cool stuff.
Yeah, getting a response back from a model with 100 billion parameters in under a second takes a lot of tricks. They basically fall into two camps. You've got output approximating methods, like quantization, which make the model faster by using less precise numbers. It's close enough. But then you have output preserving methods, like the amazing flash attention, which completely rewires the math to be way faster without changing the final answer one bit.
And check out this number, because it shows just how far things have come. We're talking about the context window here, which is basically the model's short-term memory. The first models could barely remember what you said a few sentences ago. Now, models like Gemini 1.5 Pro have a context window of over 1 million tokens. That is insane. It's like handing it all 7 Harry Potter books at once and asking it a question.
So, what's the bottom line? Why does this all matter? Well, because this technology is changing pretty much everything. It's writing code for developers, summarizing dense legal documents, powering chatbots that feel human, translating languages in real time. It's even helping scientists make new discoveries. The list of applications is just exploding.
And the next big thing, it's already here. It's called multimodality. See, the newest models aren't just about text anymore. They're being built from the ground up to understand images, audio, and video, all at the same time, all seamlessly. And that is going to unlock a whole new world of possibilities that we're only just starting to dream up.
So think about it. In just a handful of years, we've gone from a clever idea for translation to these massive, multimodal models that are changing the world. The speed of progress is just staggering. And it really leaves you with one big question. With things moving this fast, what's next? What kind of incredible new things will the next generation of LLMs be able to do? And that's the really exciting part. Thanks for joining me for this deep dive.